what you get is we have two lenses. The first lens is called the objective lens. Because it's close to the object. The object will be out here. And then this lens is called the eyepiece. And that's a better name than they used to have for it. They used to call this one the ocular, close to the eye, and the objective, close to the object. But I clearly does this. And what we're going to do is we're going to run the eyepiece as a simple magnifier. So the thing we just talked about type of idea. Okay. And so we're going to have our object. So this is our object. And if we want to view the final image with a relaxed eye, then that implies that the image can be out at infinity. And in order to put our image out at infinity, the object has to be at the focal length. For the eyepiece. So we're going to have a focal point for the eyepiece, and we're going to have a focal point for the objective lens, and they might call this a 1 and a 2 for the first lens and the second lens, like this. And so to form remember, the image out of the first lens becomes the object for the second lens. The object out of the eyepiece becomes, the image out of the eyepiece becomes the object for the eye. And if you're going to view it out at infinity, I need the image from the eyepiece to be out at infinity. To put it out at infinity, I need my object to be at this focal point. And so, while we're not going to draw ray diagrams per se, then we'll start with our object here. It's going to form an image here at the focal point of the eyepiece. So this is that intermediate image. So the image out of the objective is the object for the eyepiece. I need it at the focal point so that my final image is going to be, out here at infinity kind of things. Okay. And they often will mark the distance from the objective lens to the eyepiece as the barrel length for the microscope. A lot of times it's like 16.5 centimeters or so, and I'm not really sure why, but that's kind of what it usually is. So this must be a design thing. And so in order to form an image on the back side of the objective lens, then my object has to be outside that first focal, right? So we got to be in that, that second range. And so while we would have that this is our object distance, the book's in favor of telling you this bit, how far in front of the focal point the object is, so that then you take that focal length plus the distance in front to get the object distance. So this is the S1. And then that'll form this distance, S1 prime. And again, since the image is, the light goes through and the image is behind, then that's a real image out of the first lens, the objective lens. It has to be at the focal point of the second lens, the eyepiece, so that you form the final image out at infinity. So then this becomes our S2 is that focal 2. And then this is S2 prime is out at negative infinity because we're doing the relaxed eye kind of things. Okay. And so if we go in and look, one of the things we can talk about is we can talk about the magnification. So the magnification of lens 1, the lateral magnification, is going to be this y1 prime over y1. And that's equal to minus s1 prime over s1. Okay. So there we go. And then if we look at the magnification of the eyepiece, so then the magnification of the second lens is, since it's a simple magnifier, then it's that, near point over the focal length of the second lens. And then we can get the total magnification. Now, at the end of last class, we learned that when you had two lenses, the total magnification was just the product of the two magnifications. And so this is minus S1 prime over S1 times our near point over the focal length of the eyepiece or lens 2. And so what they can say is that since this is usually just a little bitty bit, then very nearly S1 is nearly F1. And so sometimes they make that approximation, but I think in a lot of cases in our book, they just have you run the lens equation. We still have that 1 over focal 1 is 1 over object distance 1 plus 1 over image distance 1. So we can calculate where things go. And so we can find those exactly. N will be 25 centimeters unless they state otherwise. And then the focal here is the focal of the eyepiece. So this is the setup. Image out of the first becomes the object for the second. It has to be at the focal of the second one to form a final image out at infinity to view with the relaxed eye. So let's do an example.